Using ecosystem function in the Clean Water Act is a report that I wrote under contract for EPA with the co-author Joan. And the presentation tonight is based on this report with some additional material. Ecosystem restoration for water quality starts with scientific studies of stream restoration. Here's an example of Bear Creek in Central Oregon that began with introducing stabilizing riparian vegetation to trap sediment. In August 1998, you can see that the water temperature shown in blue is cold and the air temperature shown in red is warmer. This is a result of recharging of the cold groundwater that cooled Bear Creek. Non-point source, getting to the main part of non-point source pollution causes the majority of water quality impairments in the United States. A GAO survey found, of various control plans, found that 52% had, majority were non-point sources. Agricultural non-point source pollution is the major source of the problem, and here's an example from Iowa, and streams without conservation buffers have much more pollution. The role of riparian proper functioning condition is to protect the stream banks, and that allows them to perform filtration, to reduce the flow of pollutants, and to store pollutants. The agricultural riparian buffer shown here is a demonstration project from the USDA, and it functions, as you can see, quite differently from the earlier picture. This does protect the stream. Riparian proper functioning conditioning assessment is looking at the ability of the ecosystem to reach its potential to control non-point source pollution, and it includes information on these three components: vegetation, soil landform, and hydrology. It's important to consider the context of potential natural conditions. So we see here in the Colorado River and the Grand Canyon, its natural condition is warm and sediment laden. In the high mountains, a lake is cold and clear water. The ratings for proper functioning condition, using the example we had, we could see that May 2007, Bear Creek was in proper functioning condition. It was non-functional when it started, and there's an in-between classification of at risk. Restored riparian wetlands can reduce the dead zone. This is a picture of nitrogen that promotes the dead zone, flows with the sediment that you see in the picture into the Gulf of Mexico. The legacy nitrogen amplifies the problem. The failure to meet the dead zone action goal set by the federal government, the goal is to have this area be about the size of Delaware. The average is running 3 times that. And adaptive management for non-point source pollution, it combines ecosystem function to look at early changes in physical processes with water quality criteria and integrating the data. Adaptive management has challenges in privacy, access, and free speech. You have examples where public access to spatial data on private lands is a real problem, and citizen science for pollution data actually has caused a real legal flap in Wyoming. Managing without the Clean Water Act mandate for non-point sources, we've been dealt with. We actually heard a little bit of this. There's more stringent standards from the states. There can be environmental conflict resolution, and there can be financial incentives. The example of harmful algal blooms in Western Lake Erie, public discussion in the state of Ohio is actually considering more stringent state standards to address this. This causes problems for the drinking water systems there. There are many sources of financing. The EPA Smart Growth Program has reviewed a lot of this information, and this could be part of the planning for the nitty-gritty at the local scale planning. Now, restoration, this shows an example of restoration of a stream in Nevada. When it began, it was not resilient to drought, but after restoration of the floodplain functions, it was able to keep flowing in a severe drought. That was the later picture. Sediment in the Connecticut River had a massive, result of massive erosion from Tropical Storm Irene in 2011. And this is another example where use of ecosystem function to restore the streams could reduce that. So looking ahead, we see the physical processes driving ecosystem functions connect water quality, riparian and restoration, and ecological resilience. And so the question is, how do we build the partnerships, foster them, sustain them for using ecosystem function in the Clean Water Act? Thank you very much.